Hey students, welcome to our first video of Unit 18, or 8. This is our last unit here, and we're going to talk about molarity. This is 8.2, molarity. A couple of things that you need. You definitely need a calculator, and you'll want your periodic table because we will need both at some point. So let's jump right in. We have defined solutions as a homogeneous mixture. And remember, homogeneous means it's the same throughout. So we're talking about substances that are now in the same state. All right, other little vocab that we got there. We have a solute. This is the substance being dissolved. Substance being dissolved. Our solvent is the substance doing the dissolving. Most of the time, this one is in a higher concentration, or we usually have more of it, but that's not always the case. All right, moving on to a saturated solution. A saturated solution is one in which we have no more solute can be dissolved at that temperature. So we would consider it like full up. All right, so it is considered full, if you will. No more can be dissolved. If we add more, it will just drop to the bottom. All right, then we have an unsaturated solution, and so that means more solute can fit, if you will. All right, and we can say more can be added so it dissolves, right? And last but not least, we have what is called a supersaturated solution. In this case, we have too much solute dissolved. This is a highly unstable situation, and a lot of times this is where we have, let's kind of erase that last part there. All right, we have a highly unstable situation, and what happens is it sometimes will come out of solution. Rock candy is actually made this way. All right, let's move on to molarity. This is where the math is going to come in. Molarity is our moles of solute per liter of solution. So this is how many moles can be dissolved per liter. All right, our formula then is molarity, capital M, is equal to moles over liters. So it's pretty simple. We're going to make a little triangle out of it, much like we did with our density triangle earlier in the year. So here we have capital M, that's molarity. On top we have moles, that's liters, all right? Sometimes we're going to have to go from moles to grams, and we do that by multiplying by molar mass. And sometimes, just like in the last chapter, we're going to have to go from grams to moles. And this is where we divide by molar mass, and that's what we're going to use our periodic table for. So let's kind of take a peek at a couple of examples here. All right, hopefully we can still see that. All right, so it says to calculate the molarity of a solution made by dissolving 0.750 grams of Na2SO4 to make 500 milliliters of the solution. So our first step, notice how we have grams. We have to get to moles first, so we have to take our grams to moles. So we're going to do a little aside over here and find the molar mass of Na2SO4. Just a quick review on this. We have Na, we have two of those, so we're going to take that times the number we see on the periodic table, 22.989770. And then we have S, we have one of those, so we're going to take that times 32.066. All right, and we have O's. We have four of those, 4 times 15.9994. And that's going to give us 63.9976. And then we have, so this will be 45.97954. Notice how I have not yet rounded. All right, we saved the rounding for the very end. All right, we add all that up, we're going to get 142, and now we round to 2 decimals, so we get 142.04 grams per mole. So that's our molar mass. That was kind of a little aside there working, and now we're ready to do some work. So let's kind of look up there. We've got to go from grams to moles first, so we're going to divide by the molar mass, and we can actually do this all on one little T-chart. So we've got 0.750 grams of Na2SO4. And we're going to divide by the molar mass, 142.04 grams, 1 mole of Na2SO4. All right. And now we're supposed to divide by liters. So remember, when we go from milliliters to liters, we divide by 1,000 or move the decimal 3 places. So if we move the decimal 3 places, that gives us 0.5 liters. And we're just going to divide to get moles over liters. So our goal is to get moles over liters. So now we're ready to just calculate this. Throw it in our calculator. And we're going to take 0.75 divided by 142.04 and divide by 0.5. And when we get this to 2 decimals, we have 0.0, and now we need 2 numbers. We need 2 non-zero numbers, so it's going to be 1, 1, and our label is molarity. You could actually put Na2SO4 on it if you wanted, or you could leave it off, your choice. All right, I like to put it because I like to be specific, but we're good either way. All right, makes sense? So let's see if we can work backwards. Now we've worked forwards, kind of in the forward direction. Let's see if we can't work backwards. So this time, we are looking for grams, 50 mils, 0.44. So we're going to be working backwards. If we remember, cover up what we're looking for up here. We're looking for grams. So we're kind of looking for this up here. So we're looking for moles initially. Right, so we're going to take molarity times liters. So let's do that. Move our decimal 3 places. All right, so we're going to take molarity times liters will equal moles. All right, so we've got 0.488. My decimal kind of got away from me there. Times 0.050. All right, this is going to give us our moles. All right, let's do that math. And we're going to get 0.0244, but this is going to be moles of potassium dichromate. So we have a little extra work to do there. We're at moles, and so we need to get to grams, so we're going to take it times the molar mass. So kind of a little aside over here, just like we did before. K2Cr2O7. This one's going to be kind of a big one, so we've got 2 times 39.0983. And we've got Cr2 times 51.9961. And we've got 07 times 15.9994. So let's go ahead and put this in. 2 times 39.0983. And we get 78.1966. 2 times 51.9961. We're going to get 103.9922. And then we've got 7 times 15.9994. Sorry if you can't see that. There we go. And we should get 111.9958. We're going to add those 3 up. Again, notice I have not rounded yet. And we're going to get 294.18, and that's our grams per mole. And so to get from moles to grams, look back up there, moles to grams, we're going to multiply by the molar mass. So we can just multiply by our 294.18, or that number that's just in our calculator, right? And so we're going to times that by 0.0244, and we should get an answer of 7.18 grams of potassium dichromate. And there you have it. That's examples of both ways to work this. All right, see you next time.